Hello, hello. Hope everyone is doing well. We are looking at the first topic in geometry today. So you want to make sure that you have your note packet out. So I have a copy of my note packet here. We are going to be taking notes with this note packet. So make sure that you have your copy out, or you can just follow along on a piece of paper if you need to. But we are looking at topic 1 today, which is super exciting. What we're going to do is topic 1 is all about measuring segments and angles. I'm actually going to minimize this because I lost my tools. So we're all looking at measuring segments, measuring angles. How do we know what an angle measure is? How do we know what a line segment is? Things like that. So we have 4 objectives for today's lesson. Our first objective is we're going to come up with precise definitions of an angle and a segment by using our definitions of what is a point, what is a line, what is a plane. Okay, then we're going to use absolute value and the segment addition postulate, which we will talk about, don't panic. Then we're going to use the protractor postulate and the angle addition postulate, which again we'll go over. And then we're going to identify congruent segments and congruent angles. So congruent means the same, or the same length, or the same measure. So we're going to say, hey, are these 2 line segments the same? Are these 2 angle measures the same? So what goes along with that today is there's a lot of new vocabulary. So we are going to focus on our new vocabulary, right? All of these guys right here says all my new vocabulary and all of my theorems and postulates. So in your packet, right, you should have your note packet. Mine's already filled out, but you should have your note packet. At the very back of your packet is the page that says vocabulary, or maybe it says terms, and then also theorems and postulates. So what I want you to do is I want you to go to the back of your vocab or of your packet where it says all that, where you find all the vocabulary, and we're going to go through and we're going to define all of this vocab. Okay, so here we are, and I do apologize. I said that it said vocab, but it's actually terms, but it's the same thing, so we can manage. Okay, so we're actually going to go through quite a few vocabulary terms, just so that we have a good basic understanding of what we're starting with. So let's just look. Our first term here is undefined terms. Okay, so the definition of an undefined term is a term or word that doesn't require further explanation or description. So we have 3 undefined terms that we're going to be looking at this year, or really just in this unit. The first one is a point. Oops, sorry about that. Something weird is going on. Okay, so here we are in the back of the packet, and we're under where it says terms because we're going to be looking at our vocabulary. Okay, so we have a lot of vocabulary, to cover, so I'm just going to go ahead and get started. Our first term is an undefined term. So an undefined term is a term or a word that doesn't require any further explanation. We don't have to describe it more. It's already pretty much there for us. However, I am going to go through and we're going to talk about the 3 undefined terms that we're going to look at today. So the first one is a point. I'm just going to draw a point, and I'm going to label it point P. Okay, so point P, a point is considered an undefined term. So right here, the definition of a point doesn't have any dimension, so it's not 3D, it's not 2D, it's just a point. And it doesn't have like a size either. It's represented just by a dot, so we just call, there's the dot, and then we usually, a point is always labeled with a capital letter. In this case, again, I'm going to use P. Point P is, if we're just talking about a random point, it's usually a point P. So what we would say, I'm going to put this in quotes, is we would call this point, oh boy, I'm all jumpy. Point P. So that's just how you would say it. If I'm talking about this point right here, I would call it point P. And the thing to note is that you always use a capital letter. So that's really, really important. Okay, so you always use a capital letter. So I'm going to go ahead and not, well, that's fine. Always use a capital letter. And for some reason, this is your warning for all the other videos that we will be having. Screencastify starts to get really jumpy with me after a while, so we'll make it work. Okay, so we always use a capital letter for point P, or really just any point, you have to use that capital letter. Okay, the other undefined term that is common is a line. And a line, okay, I just draw my 2 points, pretend that that is straight. Okay. And there's my line. So that is an undefined term, meaning when we're talking about something else and we use the word line in it, we don't also have to define the word line. Okay, so a line, it's one dimension, okay, and it extends in both directions without ending. So you can have 2 points, well, you need to have at least 2 points on a line. So I'm just going to label this point, let's just say R, and this point S. Notice that both my points are capital letters. Okay, and then a line just connects the 2 points. And then it goes on forever in both directions. And that's really important. It just keeps going. Even though I have this point R and I have this point S, it's still going on in both directions. And then we usually label our lines with a cursive lowercase letter. I know you guys are thinking like, oh, cursive, we never learned that. It's okay, don't worry. So that's an L, a cursive L sometimes we'll use, or a cursive M or N sometimes we'll use. Okay, so we would call this line L. There, that's much better. So line L. And then that's how we would say it. So I'm going to put it in quotes because that's how we would actually say it. We would say line L. If we were writing it, we could say, we would write our R and our S. And we could draw a little line above it with arrows. So that represents line RS. But since a line goes forever in both directions, we can actually do SR as well. And that's totally fine. So hopefully that makes sense. Either way is good. Okay? So that's the definition of a line. Our plane is our last undefined term. So I'm going to kind of draw like a little parallelogram here. And I'm going to label it Q. Capital Q. It's like the hardest letter to draw in a small space. Okay, so a plane is a two-dimensional flat surface that goes in all directions. So think about when we have a coordinate grid like an XY axis. That is a plane. It goes on forever in both directions. So you could draw, I'm just going to draw another parallelogram. I extended it a little too far. So a plane has to have at least one point in it. Okay, so it has to have at least one point. It can have more than one. That's fine, but it has to have at least one. So I'm going to draw a point, and I'm going to label that point Q. Okay, it can have more than one. You can have point Q, point R, and point S in there, and point P. You can have all sorts of points in there. But for now, I'm just going to label one, and then we would just say in quotes, plane I'm going through a jumpy spurt. Plane Q. And then that's how we would write it too. So we would say plane Q, but then we would also write plane Q. So those are our three undefined terms. So those, what we're talking about there is I can now use these three terms to define other terms. So I'm going to go ahead and clear these notes and scroll down so that we can look at the next couple things. Nope, my scroll down button doesn't work. Okay, so let's scroll down and we're going to look at our other terms. All right, so next term is a segment, which is going to be used a lot in this lesson. So a segment is part of a line defined by endpoints. So it means you're taking that line that goes on forever, but you're cutting it off at two endpoints. So if I have, let's say an endpoint A, and then over here, I have an endpoint B. Okay, a line would just go all the way through and continue on forever. But a segment, or sometimes called a line segment, stops at those endpoints. It doesn't go on further. Okay, so this is segment AB, right? So how we would write that is AB. And then instead of drawing a line above with arrows, I just draw the straight line above. So that tells me it's a line segment. That tells me it starts at A and it stops at B. Or if you go right to left, it could start at B and go to A. And that's totally fine as well, as long as you draw that line above it. So either one of those is correct in that, okay? Array is kind of combining the two. So it's a line that starts at a point. So let's say it starts at point A, and then it just goes on forever. So I can still have 2 points that it goes through as such. but it's going to continue on forever just in one direction. So I think the way that maybe this was presented to you is like a sun ray, right? Like this, the ray comes from the sun to the earth. It starts in one spot and it goes on forever in the other spot. So again, I can write here A, B. Oops, lost the second half of my B. There we go. And then because it starts at A and goes to B, I'm only going to have an arrow on one side. That tells me that it continues forever through B, but it starts at A. Could you write it the other way? Not in this case. However, if you had a different ray that was going this direction, then you could write it the other way. Let me go ahead and erase that so it's not confusing. Okay, so wherever it starts, that's going to be your first letter, and then when it goes on forever, that's going to be your second letter. Okay, moving on to angle. An angle is two rays with the same endpoint, which is called a vertex. Okay, so I'm going to draw an angle. So here's an endpoint. I'm going to draw a ray that goes up, and it's going to go into the other box, but that's okay. So there's one endpoint. There's the other endpoint. So I'm going to, in this case, I'm going to call this A. And this is my vertex. So I'm going to make a little arrow. This is my vertex. So A is my vertex. Okay? And then we can call this point B, just for fun. And we can call this point C. Well, that was a terrible C, but that's okay. Okay, so here's an angle. We know what an angle is. We've seen it before. It's all good. But do you see how I have two rays? I have ray AC and I have ray AB, and they meet at the same vertex. So that creates an angle. There's multiple ways that we can write this. We can write angle, and so this is the symbol we use for angle. It looks like a little angle, right? So angle A is one way that we can write that. Or, okay, real jumpy. Or we can write angle 2. And how that would work, I'm just using the 2 as an example, is if this was called 2, right? We could call it angle 2. Or we could call this angle BAC. And the reason I'm going B to A to C is, what direction would you take your pencil to draw this angle? You would go from B to A to C to trace that angle. So B, A, C. Or you could take your pencil and trace C to A to B, and that would also be correct. So you also could do, instead of BAC, you could do angle CAB. So all of those are used to describe the exact same thing. It's all an angle. Okay, moving on to a postulate. We're going to use this word a lot. It's an accepted statement that needs no further justification. So if you are given a postulate, you can assume it to be true. So that's the thing about a postulate, is that it's assumed. Oh, I need my pen to not be so jumpy. Holy moly. Sorry, guys. I'll figure out why it's being so jumpy, and we'll figure it out and get it fixed for next time. Okay, now it's going. So assume to be, my pen really doesn't like me today. True. So if I tell you this is the angle addition postulate, you can just go ahead and assume that it's correct. Okay. Okay, moving on to collinear. I promise most units do, or most lessons do not have this many vocab. It's just because it's the first one. So our next one is collinear. So co means to share, right? Think about colleague, right? Colleague has that co, somebody that you're working with. When you have co-teachers in your classroom, it's two teachers who are working together, things like that. So co is together. Linear has that word line in it. So this is a line together. So to share a line. So if I have, let's say, a line, there's my non-straight line. Well, it's okay. And I have points on this line. So let's say that this is S. This is, I'm just going to make up letters A, and this is T. S, A, and T are collinear points. So S, A, and T are collinear because they are all on the same line. Okay, so they are all on the same line. If I had another point P that was out here, that would not be collinear because it would not be on the same line. Okay, so hopefully this is making sense so far. We're cruising. We're almost done with terms. Now we're going to talk about congruent segments. So congruent means the same. So here's that word, same, the same. Okay, congruent means the same. Segments, congruent segments are segments that have the same length. Here's my definition of a segment, right? Endpoint to endpoint is a segment. So if I have a segment, make that a little bit bigger. Here's a segment with two endpoints, and I'm going to call one endpoint A, and then the other endpoint B, just for fun. You can call it whatever you want. And then let's say I have another line segment. And just for a lack of creativity, let's do C and D. If these two line segments are the same length, we can put a little dash through the middle of the. Oh, hold on. So sorry, we have an announcement. Okay, so if these two line segments are the same length, we put a dash through them to show that they are the same length. I don't know what the length is, and it doesn't matter. It could be 3, it could be 7, it could be 100,000. Okay, it could be whatever. But if they are the same length, we can put that dash through them. And then how we write it is line segment A, B. There's AB, and I know it's a line segment because I put a line above it. And then we do an equal sign with a little squiggly. I know there's a name for it, but I don't remember what it is. This means congruent. Okay, so this tells me AB, line segment AB is congruent to line segment CD. So hopefully that makes sense. It tells me that, hey, this line segment and this line segment are the same length. Do we know what the length is? Not necessarily. Maybe we do, maybe we don't. But we do know that whatever the length is, it is the same. Okay, getting close. Two more here. The next one is congruent angles. Same thing. Congruent means the same. So this just tells me that I have two angles. So I'm going to draw one angle here. And let's label this B, A, T, just for fun. And I'm going to label this one. I'm going to draw another angle. And let's label this M, E, N. Come on now, there we go. Okay, so do I know what this angle measure is? No, it could be 90, it could be 30, it could be 2, it could be 359, right? It could be anything. But if I know that they're the same, I draw my angle markings and I can put a little dash through that angle marking. So this tells me these two angles are the same. Do I know what the angle measure is? Not necessarily, but I do know that the angle measures are the same. So then I can say that angle, so you always have to draw that angle symbol, B, A, T, is congruent to angle measure. So if I go from B to A to T, I have to go in the same order on the other angle. So if I go BAT, I have to go MEN. If I did TAB, I could go NEM. So just make sure that you always go in the same order. So BAT is congruent to angle measure MEN. And again, I have the equal sign with the squiggly above it. So hopefully that's making sense. We do have one more to do. So I'm going to go ahead and scroll down here. Okay, so the last, there we go. The last term that we have for today is coordinate. And you'll hear this a lot. You should already know the word, but we'll review it. Coordinate is a real number that corresponds to a point. So if I have a number line, for example, oh, I can do better than that, right? You can do better than that. Okay, so there we go. So if I have a number line, remember number line goes on forever, both directions, because it's a line. And let's just call this 0, 1, 2, 3, and so on. And then this direction will have negatives, so -1, -2. Okay, so if I have a point, I need a point, so let's do a point here. And we're just going to call it X. Does that make sense? Hopefully we got that going on. So -1 is the coordinate of X. So I can say X equals -1. And if I have another one, let's say here at 2, we can call it Y then the coordinate of y is 2. So y, here we go, equals 2. So just a nice little review of what it means to be a coordinate. The only other thing that we have to go over here is some postulates that we're going to need to know for this unit. So go ahead and turn your page until you find the postulate page, and then we'll get started on those. Okay, so hopefully you found this page that has postulates, theorems, and formulas. We just have these 4 postulates that we're going to talk about today. The first one is the ruler postulate. Let me get my pen back. Okay, so the ruler postulate just tells us that every point on a line can be paired with a number. So that's just what we talked about with coordinate. Okay, this number is called the coordinate. Hey, I just said that. Okay, so like here, coordinate of x is 3. The coordinate of y is 7. Okay, so you can actually put it up against a ruler. So that's kind of the difference for the ruler postulate. That I can take any point on a line, like even this point, and it would match up with a number on a ruler. Okay, so the segment addition postulate. It says if B is between A and C, so I'm going to draw a segment. So here's my segment. And it says if B is between A and C, so this is A, and this is C, and B is at a random point between the two. Doesn't have to be in the middle. It can be, but it doesn't have to be. All it tells me is that B is between A and C. Then A to B, so from A to B, right there, that distance plus the distance from B to C equals the whole thing, A to C. So hopefully that kind of makes sense. If I have the length of A to B, so think of it like pieces of wood. If I have a piece of wood that's the length from A to B, and then I have a piece of wood that's the length from B to C, and I put them together, then that piece of wood is the length from A to C, is the total length. So the lengths have gone together. Okay, so the next one is the protractor postulate. We will be looking at protractors a little bit in this class. So it says, given I have a ray, notice how the ray is written, right? An endpoint on one side and an arrow on the other. So given ray BA, so right here from B to A, and a point C, here's point C, not on that ray, it's saying if I have a ray and a number not on the ray, or a point not on the ray, those 3 points create an angle. So now A to B to C has created an angle. In this case, angle ABC is 60 degrees. If C were to move to somewhere else, the angle would change. And the last postulate is the angle addition postulate. So it says if point P, I know it's a point because it's capital, if point P is in the interior of an angle RST. Okay, so I'm going to go ahead and draw that angle first because I want to visualize this. Again, I can do better than that. I wonder if it's because my writing tablet's at an angle. I keep drawing everything at an angle. Let's see if I can fix that for you guys. Okay, so I'm going to draw R to S to T. So here's my angle. It's just kind of random. I don't need to draw it perfectly. So R, S, T. Okay. And point P is in the interior somewhere. Let's say here. All it's saying is it doesn't matter where point P is, but it's somewhere in this angle. Okay. Then the measure of RST, so this whole thing is the sum. Sum means add. I'm going to switch color here again. Okay, is the sum of RSP. Let's drew that line a little too far. That's okay. So this angle plus this angle, PST. So RSP, so this angle, plus PST, which is this angle. If I add those two angles up, I will get the whole RST. I will get the whole thing. So that's just saying I can add two angles together and get a larger angle. Just like the segment addition postulate says I can add two segments together and get a longer segment. So hopefully that makes sense. Those are all of our postulates, theorems, vocab for today, for today's lesson. I know that was really long. I promise it won't normally be that long. We don't normally have that many. So I'm going to go ahead and stop the video, and then when you watch the next video, we'll actually get into the lesson.